All right, in this example, we're going to look at a long straight wire. And remember that when we define long straight wire, all we're saying is that we're sufficiently close that even if it's not an infinitely long wire, the approximation that we get is more than good enough for the number of significant digits or for the level of precision that we actually need. So first, let's draw a picture of the situation. The wire is going to be long and straight, and in order to enclose the electric field, which is perpendicular to this wire, if we look at the wire on end, remember that the electric field points radially outward. So if we want to enclose that field, we're going to have to put a cylinder around the wire, and everywhere at that location R, it's going to be a uniform field. So the cylinder is going to go around the wire like this, and the cylinder has a length of L. It's an arbitrary length. It's going to have a radius, which is R. It's going to be little r. And remember that the electric field, it's uniform everywhere at that point because the electric field is uniform all along that line, all the way around. You're going to see that this is a pretty quick and easy process. So let's do Gauss's law. We have the integral of E dot dA is equal to Q enclosed over epsilon naught. And we have three surfaces to consider, but this time, instead of using the end caps or the circles, because the electric field is going to be parallel to the end cap or the circle, we can ignore those and we're only going to consider the wrapper. So we know the field is uniform everywhere along the wrapper, and that the integral of dA, or that wrapper, is going to become just the area of the wrapper. So we get E times 2 pi RL is equal to Q enclosed over epsilon naught. And that Q enclosed is going to be dealt with using charge density. If you actually know how much charge is enclosed, that's fine. But if you don't, then you're going to use charge density. And we know that lambda is equal to Q over L. So Q enclosed is equal to lambda L. And that's going to be the length of our cylinder. So we get E times 2 pi RL is equal to lambda L over epsilon naught. And we're going to cancel out the L, and that's going to leave us with E is equal to lambda over 2 pi epsilon naught times R. And it is just that simple to use Gauss's law.